Hello, my name is Antonio Rivera, and along with my classmates Jana DeMotz, Madison Introvici, and Dakota Reeves, we've tested motion in the y-axis and have proved that motion in the y and x-axis are independent of each other. The following is a clip of us dropping two golf balls, one straight down and one with a non-zero x velocity.
As shown in the video, despite one of the balls being given an x-axis constant velocity of 1.052 meters per second and traveling 0.38 meters, both balls hit the ground at the same time. Not only does this prove that the x and y-axis are independent of each other, but that there is a constant acceleration applied in the y-axis, gravity. Objects that are in free fall or that are only affected by gravity fall at a rate of negative 9.81 meters per second squared.
There are a few kinematic equations that use this concept and support our data. The first equation we're going to be looking at is delta y equals vt plus 1/2 gt squared, in which delta y is the change in distance, v is velocity, t is time, and g is gravity. Using this equation, we can reinforce that gravity is negative 9.81 meters per second squared, or that half of gravity is negative 4.905 meters per second squared. The vt part of this equation is irrelevant because our object's initial velocity is 0, leaving us with the equation delta y equals 1/2 gt squared. After using logger-pro to plot points and assign a best fit curve, we found that our a value was negative 3.835. This is close to the actual value of half of gravity. We encountered a 22% error in our calculation due to the limited distance the software had to make a proper line. The second kinematic equation we're going to be looking at is vf squared equals vi squared plus 2g delta y. Similarly with the first equation, initial velocity squared is irrelevant because our object started at rest, therefore leaving us with final velocity squared equals 2g delta y. We can now take the square root of 2g delta y to give us the final velocity of the ball just as it hits the ground. Now we just have to plug in our perspective points. 2 times gravity times our change in distance, negative 0.0718, which gives us a final velocity of 1.19 meters per second.
What you are currently looking at is a displacement graph in which the rectangle represents the product of velocity and time, and the area in the triangle represents the product of 1/2 gt squared. By adding these two portions, we get the overall displacement, or vt plus 1/2 gt squared. In this experiment, the displacement graph would look more like this because the object started at rest.
Using our observations and data collected using logger-pro, our two kinematic equations, and our displacement graph, we've determined that x and y-axis motion are independent of each other. Thanks for watching.